Welcome to this comprehensive tutorial on how to implement a card game, specifically Solitaire, using Java. In this series, we'll walk you through the essential components of game design, coding, and user interaction. By the end of this tutorial, you'll have the complete code for your own Solitaire game and a solid understanding of game development principles. Before we dive into coding, let's briefly discuss the core components of Solitaire. Solitaire traditionally uses a standard deck of 52 cards, and the objective is to move all cards to 4 foundation piles while following specific rules. We'll create classes for cards, decks, and the game itself. Let's start by creating a class to represent a card. This card will have a suit and rank. First, open your IDE and create a new Java file named card.java. In this class, we define 2 fields for the suit and rank of the card. We've also included a constructor to initialize these values and getter methods to retrieve them. The toString method provides a string representation of the card. Next, let's create a deck class that represents a collection of cards. The deck will handle card shuffling and dealing. Create a new file named deck.java. In the deck class, we maintain a list of card objects. We initialize the deck in the constructor by adding all 52 cards. The shuffle method randomizes the order of the cards, and the deal card method removes and returns the top card from the deck. Now that we have our card and deck classes, let's create a game class to manage the game logic and user interaction. Create a new file named solitaire.java. In the Solitaire class, we hold references to our deck, a list of Tableau piles, and foundations. The setupGame method initializes the Tableau by dealing cards into 7 piles. We also have a displayTableau method to print the current state of the Tableau. Now let's create a simple main method to start our game. We will set it up in solitaire.java within the main method and create an instance of our Solitaire class. Now we can run our program. When you execute it, you should see the Tableau piles printed to the console. This means our cards are being dealt correctly. However, there's more to do to complete our Solitaire game. Next, we'll need to implement the game rules. Solitaire has rules for moving cards between Tableau piles, foundations, and the draw pile. Let's start by adding the functionality to move cards from one Tableau pile to another. In this move card method, we check that the provided pile indices are valid, ensuring we don't access elements beyond the bounds of the Tableau. We then remove the top card from the source pile and add it to the target pile. Let's enhance the moving cards functionality to incorporate Solitaire rules, such as only allowing moves that maintain the alternating color and descending order of ranks. We need a method to check if moves are valid. This set of methods allows us to check if a move is valid based on the colors and ranks of the cards. The isValidMove method will be called from our moveCard method to ensure we only allow valid moves in the Solitaire game. Let's go ahead and update our moveCard method to call isValidMove. You can also consider adding a method to update the state of the Tableau after a move, like flipping the next card in a Tableau pile when the top card is removed. Let's implement functionality for the foundation piles. As you may know, in Solitaire, players build each foundation in ascending order of cards of each suit. Thus, we will need some methods to manage these foundations. This move to foundation method checks whether a card can be added to a foundation pile. It validates against the existing top card of the foundation. Now that we have the core mechanics in place, let's create a simple text-based user interface that allows the player to input their moves. We'll add more interactivity to our game by handling user commands. In this updated main method, we use a scanner to take input from the user and process the commands to move cards or move them to foundations. This is a great step towards making the game playable. Next, let's enhance our user interface by providing feedback on invalid moves. When the player tries an invalid move, we will inform them of the error so they can adjust their actions. We can do this by printing messages directly from our move methods. It's essential for the player to understand the game's state at each point in time. Adding visual flair, like showing the face-up and face-down cards clearly in the command line, can be beneficial. Use different symbols or formatting to denote these states. To implement the state of face-up and face-down cards effectively, we would need to enhance our card class to have a Boolean flag indicating the card state. Moreover, we'd need methods to flip cards over after moves. With the logic for card flipping established, let's ensure that during a move, if a card is moved from a pile that now has 0 cards, we flip the next card to face up in that pile. Update your move methods accordingly. As we approach the completion of our game, let's integrate a simple scoring or win condition. For instance, we can check if all foundations are filled to declare victory. We can then implement a check in our main game loop to see if the game is won after each move and print a corresponding message. With these enhancements to the game's logic and structure, we have a playable version of Solitaire. However, we can always add more features later. For now, let's summarize what we have achieved. We have organized our code into manageable classes for the card, deck, and the game itself, implemented the game rules, created a simple command line interface, and improved user interaction. Plus, we've laid the groundwork for improved visual feedback and game state management. This is a strong foundation for future enhancements or a graphical user interface. Thank you so much for following along in this tutorial. I hope you gained valuable insights into game development and Java programming. If you have any questions or would like to suggest features or improvements, feel free to leave a comment below. Don't forget to subscribe for more programming tutorials, and happy coding!